Cool. Thanks, everyone. So we had a little talk earlier that there's a lot of beginner content for APL and not so much intermediate content, also lots of high-level content. And my job here is to introduce even more beginner content to the mix. So before I begin, let me introduce not just myself, but my team. So I'm not working on this alone. We are 3 students from the University of Helsinki. So we have Danny, Hex, and myself. And I originally got this idea a few years ago and then brought Danny and Hex on board, and we've been working on this ever since. But I'll get to that soon. If you want our contact details, they're right here, along with our GitHubs. Just a little more about myself, because I'm here presenting. So I am a bachelor's student, or I finished my bachelor's at the University of Helsinki in maths, and I'm really excited because I am going to Oxford in about 2 weeks' time, beginning my master's there. So, thank you. Other than that, I work in cybersecurity. So I work as a hacker. I call myself a hacker. I hack into systems and exploit them and find cybersecurity vulnerabilities. And also, I'm a novice APLer, so I wouldn't consider myself anything above maybe a beginner. But there we go. If you want to email me, here's my cool URL that I made for myself. Some little more facts. This is my favorite APL function. Can anyone tell what it does? No. Okay, 3, 2, 1. It makes this nice pyramid, depending on the input size. And since I know that there's a lot of Dyalog people listening, I'm going to just quickly present my language feature suggestion that I want to see implemented, and that's lamp reduce. That will make a multi-line comment using a lamp reduction. Anyways, that out of the way. Let's get back to the actual topic at hand. So APL has a major unfair disadvantage when compared to other languages. And that's just simply the fact that other languages are taught in schools, while APL isn't. So, you know, that's a pretty big issue, because since if you don't have introductory material in schools, if you don't have students actually taking up courses on programming languages, they'll kind of develop tool chains, develop methods of working in other languages and focus on them instead. For example, at the University of Helsinki, all our students, since day one, they're taught to program in Python. Then, depending on their track, they'll either move on to like programming with performance in C, or programming for web in JavaScript, or functional programming in Haskell, and we have courses on all of that. But array programming, which is a separate paradigm in and of itself, is never introduced. So it kind of, well, no one ever finds out about it, no one ever uses it. Now, the way teaching works at the University of Helsinki, we have this wonderful system called MOOC. So that's the logo. And MOOC, or mooc.fi, that's, you can go there and look at all the courses. These are, let's see the acronym here, fancy animation. They're massively open online courses. Now, this is kind of a philosophy of teaching that was pioneered by the University of Helsinki. I'm pretty sure other universities do this as well, but at least I'm most familiar with it at my home university. And the idea here is that courses are open to everyone worldwide. No matter where you're from, you can go on the website, mooc.fi, and take the course. Now, the little bonus thing there is that if you're an actual enrolled student at the university, or at any Finnish university, because it's a Finnish-wide program that they've developed, you can register study credits for this. And that's kind of the key thing that I wanted to get at here. So this massively open online course, it's free knowledge for everyone, anyone's allowed to take it, and there's like automatic grading and stuff, so a teacher doesn't have to be actively involved apart from problem situations, and then it's an official online university course that anyone can take. And that's kind of the philosophy. There's plenty of different things. There's the laser pointer can't be seen here, but we have the Introduction to Programming course, which is the basics of Python 1 and 2, and then we have stuff like Elements of AI, which is actually getting really popular now. If you're into learning about basics of AI, I suggest going there as well. But the point is that all of these courses, they have automatic grading, which means a teacher doesn't have to be involved. It means students get points by submitting answers to problems, which then some sort of automatic grading system evaluates on different test cases. Yeah. Now, for study credits, a typical course, and what we're planning with this APL course, is a 5-credit course, which is good because if a study degree is 180 credits, that's 2.778, or just under 3% of bachelor's degree. So if we can fill bachelor's degree with 3% of APL, that's already good. And if there's 2 APL courses, that's already 6% of your degree being in APL. So wonderful. Okay, so these are kind of all of the courses that are available, or there's, well, lots of different ones. There's functional programming in Haskell, there's programming in Python, databases with SQL, algorithms with C++ and Python and stuff, and, well, general algorithm design. So what would it take to add APL to this list? And that's what me and Danny and Hex decided to find out. Now, before I get to the actual kind of the course itself, my story with APL and why I wanted to do this in the first place. So I participated in this math summer camp a couple of years ago, and there was this cool instructor, and he had a little workshop on, I think, the most useful esoteric programming language, which happened to be APL. And he showed us, like, different simple techniques, the kind of classic comparison of if you want to take a list of elements and see which ones are positive and negative, and then decide whether the product of all the elements is positive or negative. In Python, you can do that in maybe 10 lines of code. In APL, it's x reduce x, which is really nice. And kind of I fell in love with the terseness and the simplicity of APL, and I wanted to share that with university students and inspire them to learn more. After this summer camp, I decided to go and learn a little bit, and I checked a bunch of different tutorials. There was, I think, Stefan Kruger's tutorial online, but I particularly liked this tutorial.dyalog.com, and it's a really kind of sweet course, because we have, like, this discussion between the different creators of APL. I don't know if you've ever looked at this course, but and by the way, this whole website is made in APL as well, and that's before stuff like EWC, so which is very impressive. But yeah, I don't know who the Zark guy is, but I like their course a lot. So, but there's a lot of different things that I actually wanted to emulate with my course as well. So stuff like this course had read problems and write problems, where you would get a bunch of APL code, and you would have to actually predict the output. So kind of reverse programming, which really helped me understand some of the APL concepts. And also write programs, or write problems, where you as a user would have to write some code and then see alternative maybe solutions after you've gotten it correct. So yeah, and these are the kind of two things that I wanted to, the read and write problems, they're the two things that I wanted to replicate in my own course. So, the plan. We settled on 7 chapters of content, which is pretty typical for a MOOC course at our university. And it would have some content, which I'll show you soon what the kind of the topics that we settled on are. But at the end of each chapter, we decided that we would have a review section, which is to review all of the different symbols or glyphs and stuff that were introduced, because actually as a first timer, it's very hard to remember, what jot diaresis does, for example. So having a nice little review and how to type the characters at the end of the chapter is one of the things we wanted to introduce. And read exercises and write exercises for the actual evaluation part. Now, the way we do evaluation in our course is that the read exercises are ungraded. They're just for your own learning. You can go look through them, just click through and look at the answers immediately. However, write exercises, they're the graded ones. And so the way that works is you log in with your mooc.free credentials, and we do some hacking magic to get the session token into our database. And then when you submit some code into one of the text boxes, it'll go into our backend, and then the automatic evaluator will run it on a few different test cases. So like different left arguments, different right arguments, maybe if it's a function or a defun, and then stuff like that. And if it passes all the test cases, then you're awarded with points for that problem. And there's different levels of test cases. So for example, if you pass the simple tests, but your code works incorrectly on some edge case, like an empty vector or a zero value or something like that, then you might get partial credit for the problem. And there's no kind of penalty for getting it wrong or getting partial credit. You can just iterate and do it as many times as you like until you actually get all the points you need. And then the final chapter, chapter 7, that's on actual software development. So that's where we introduce all of the trad funds and all of the like big programming concepts, how to make a chunk of software in APL using Dyalog script or Dyalog or Ride, or we haven't really decided on that yet, on the practicalities, that is. Now, my philosophy here was that I'm going to try to cover most, if not all, of the APL glyphs. One informed decision that we made is to not include I-beam in the course at all. There's a bunch of other stuff we don't cover just because it's kind of 7 chapters logically linked together don't allow for everything to be covered. But there's always room for expanding in the future. And the plan, continued, is that the course is going to be free and open for everyone worldwide. It's literally just on our website. And the graders, or like anyone is able to submit code to the grader as well. But then if you're a Finnish or maybe even a European student, then you can get credits from the University of Helsinki, and then if you are at a different university, you can perform a credit transfer to include that in your bachelor's degree or master's degree. So my fundamental equation here is that if we have students that are hungry for credits, who want to complete their degree, and there's free credits on offer through our course, then obviously they're going to take it, and we're going to get a huge boom of APLers in the future. That's the dream, anyway. And actually, most programming MOOCs have 2 parts. We're only planning for one 5-credit part right now, but if there's good feedback and room to expand, we can do that as well. Now, let's look at the chapters a little bit. This is, by the way, the link. We're going to get back to that later. Let's look at the content itself a little bit. So this is what it looks like. It's made in McDocs. It's just, I've tried to go for a more or less conversational style, or our team has tried to go for more or less of a conversational style with the user, where we interleave prose and code and some sort of diagrams. I think Danny's been recently working on some nice p3.js 3D animations for how when you reduce an array, or like a multi-dimensional array, the dimensions get reduced into 1 and stuff like that. So we're trying to make it approachable and accessible and kind of a friendly course to work on. There's also dark mode available if you're into that stuff. But this is the general structure that we've set on. Chapter 0, because we do 0 indexing here. Quad.io gets 0. So that chapter is literally just practicalities and course information. There's nothing of substance there. But then these are the rest of the chapters here. And I'll quickly go through them one by one to see what we've planned for them in general. The first chapter is very, very basic. So that's logging onto, or not logging onto, opening try-APL and performing basic operations on scalars. So that's getting familiar with how to write the glyphs like multiply, divide, et cetera, et cetera. Getting familiar with the order of execution, right to left, parenthesizing expressions, and we have some nice exercises on rewrite this chunk of code using as few parentheses as possible to get people familiar with how to structure code in different ways. Also basic error handling, and the idea of if you see a big red error on your screen, don't panic, which surprisingly many bachelor students start panicking when they see any sort of error in any programming language. So good to get used to that. Now, chapter 2 is the basics of array programming. So that's, we start with just defining variables, the assignment operator, and then creating and manipulating 1D vectors. So basic vector, one-dimensional data, and the same arithmetic operations that we covered in chapter 1, but applied to, applied as scalar functions on a vector. Here we also introduced the concept of matrices and reshape and multidimensional arrays, and also nested arrays, which are kind of left as a little thing to avoid until a later chapter when we actually properly discuss it. Chapter 3 then is functions. So this is all about defuns and math and relational logical functions. So we introduced like the whole big set of all the different APL function glyphs in this chapter, as well as then recursion and basic 3 trains. And we also made the decision here to move trad funds over to the later chapter, so we're actually going to introduce trad funds only in chapter 7 when we're working on software development, because kind of installing Dyalog and doing all of the trad fund stuff didn't feel really right here, so we decided to leave it for later. Chapter 4, vector functions. So this chapter is on vector generating functions, for example, replicate and what others are there? Iota, the question mark generator function, like all of those functions that instead of reducing or doing operations on vectors, they produce vectors. Then reductions and scans, all the different useful and useless reduction scan operations, as well as kind of grading up and down, manipulating vectors, and selecting from a vector. Now, this chapter, I'm kind of still not fully sure about this because in this chapter we only cover the one-dimensional case. So all of these operations, all the searching is on 1D vectors. And then doing operations on multidimensional vectors is saved for chapter 5 called higher dimensions. Now, I've had many sleepless nights trying to actually rearrange this course to be in a form that I like. And this is kind of the best we've come up with so far. But maybe it would be handy to actually introduce some of the multidimensional cases here in chapter 4. We'll see. But in chapter 5, so this is intended to be a higher dimensional array operation chapter, so doing operations on matrices and 3-dimensional or higher dimensional arrays, including stuff that talks about nesting and, for example, justifying why the shape of a scalar is the empty vector, and doing stuff like transposition and rotating and et cetera on different axes. And there's this cool chapter in the tutorial.dyalog.com website called cross-tabulation, which I want to not copy-paste, but somehow appropriate to this course. And that's essentially when you have a big chunk of data in, for example, 14 dimensions, how do you process that by reducing and selecting on different axes? So that's kind of one of the keynote points that I'd like to have in this course. And then finally, chapter 6. This is kind of a miscellaneous chapter, so I've titled it Everything Else You Need to Know. Doesn't quite cover everything else in APL, but everything else that isn't harmful for you as an APL developer. So string manipulation, inner-outer products, encoding, decoding data, so working in different bases with numbers and stuff. And then basics of operators, so the repeat operator and all the weird jot-dot, not jot-dot, the jot diRCs and the other stuff that you use with 4 and 5 trains. And last chapter, programming in APL. So here we actually finally install Dyalog. We might have a reference to this earlier on in case someone wants to actually work on their PC, laptop, instead of doing try-APL the whole time. But here we finally introduce trad funds and interactive programs, file.io, maybe some libraries like installing Titan packages. We're not quite sure yet. And the kind of culmination of the course is a big programming project where students will have to make a workspace or most likely actually make a Dyalog link thing where they'll make some trad funds that do some cool operations, and they'll submit this whole big chunk of different trad funds to our grader that'll evaluate them. So instead of individual little tasks, one-liners, this will be more of a problem-solving software development project. Also, there's some bonus content. So here, this is mostly Danny's work. So he's been working on different demos that we sprinkle in throughout the course. These aren't tested or graded in any way, but these are just interesting things that some people might find curious to look at during the course of their APL studies. So, for example, how do you develop computer graphics, or how do you process image data in APL? Now this is all subject to change, so we're pretty much set on the structure, but obviously if someone looked at my presentation now and is angrily screaming like, I wish they would have done this in this place, then obviously please come talk to me, because we really appreciate that kind of feedback, and we need that to progress. In terms of progress, we're currently finished with chapters 0 through 4, and we're still working on chapters 5 through 7, so that's 3 chapters essentially left until we're done with the course. Quickly about the infrastructure, I don't have much time, but currently the user over there, they interact with our Markdown or, what's it called, McDocs front end, which is built on GitHub, and then that interacts with our Python backend, which then runs. It encapsulates their APL code in this big chunk of APL tester code, which was provided by Rich. Thank you, Rich. And sends that whole chunk off to dialog.run. And then it saves the user data and all the points they have in a SQLite database with the session token and everything provided by mooc.fi. Now, this is the kind of a screenshot of the big chunk of APL that Rich wrote that I still could not decode, even though I really tried. I'm convinced there's an APL code injection vulnerability in here somewhere. I just haven't managed to find it yet, but we'll see. We'll see about that eventually. I think, though, we are going to restructure this because the University of Helsinki uses Test My Code for most of their code testing, which is this software that does all of the reading student data and assigning students with points and evaluating code automatically. So the workflow might change this, where our front end just calls the Test My Code plugin somewhere in the University of Helsinki backend. And that'll be it. Unfortunately, though, this TMC integration is written in Rust. So TMC is Test My Code. And I have no idea how Rust works. I just started learning a few days ago, so I might do that eventually, or we might find alternative ways of doing this, but we'll see. Anyways, for the next few months, we're going to be working on the TMC integration and completing chapters 5 to 7, and then we'd want to pilot this course with a group of students and perhaps older, more experienced APL developers who can give perhaps more valuable feedback from the side of, oh, this topic is taught incorrectly, or this topic should be introduced in this way. And finally, this will be released. We've already gotten kind of a blessing from above that this can be eventually released as a University of Helsinki MOOC course that'll be accessible for students. But my final point here is that all of us, Danny, Hex, and me, we're all novice APLers, and we'd really love some help from the oldies to actually understand how we, well, if we teach this correctly, if there's something we can improve on. So if you're interested in signing up as a beta tester for this course, or otherwise giving feedback on the course content, here is a QR code that you can scan with your phone. Alternatively, on the website, aplmooc.fi, there is just a link to contact us, and that leads to the exact same place as this. And we'd appreciate it if you just put your email in the form there, and then we could contact you later on when we're about to release the course, so that you can give some feedback and we can iterate with you on the course content. Anyways, that's the APL MOOC. Thank you very much.